Hi everybody. Well, it's another beautiful, bright, sunny day here in Millcreek Township. Wouldn't it be great if we could capture all this sunshine and save it for a rainy day? Well, in a way, that's what we're doing here. The township is about to embark on an exciting new project that will harness all this sunshine and turn it into electricity. It's called solar power. Over the next few months, the township will be planning its own solar farm right here on West 26th Street. 26 state-of-the-art energy-efficient solar panels will be installed right above me on the roof, and another 90 more on a roof of a maintenance garage out back. Not only is this beneficial for the environment, but it's also expected to save Millcreek taxpayers thousands of dollars a year in energy costs. Now, how's that for making a sunny day even brighter? Generating solar energy really is a fascinating process. So join me now as we take a closer look at how solar panels work, how they're installed, and just how much energy and money can be saved by using nature to power the future. Hello, I'm here to see Joe Kuyava.
I believe he's expecting you right through these doors.
Thank you. Hi, Joe. How are you doing today?
Good. Pete, yourself?
Very good, thanks. How did the township come up with the idea of installing solar panels on the township building?
With electric and the deregulation and everything that's going on, I said we really need to start thinking about what we're going to do. You know, the projections were 30% of increase, and that just scared us. In government, you know, where do you get a 30% increase, and where are we going to get the money to do that?
The township applied for a federal energy department grant that would pay for the design and installation of solar panels, as well as other energy-efficient improvements to a second maintenance garage.
They looked at, you know, the population of Millcreek. They looked at the solar panels and the plan that was put together. Great plan with both buildings. And being it was a government building, they thought, okay, we'll see what government can do with the money that we're going to supply to them.
Millcreek was awarded a grant for $491,600. However, federal money has its stipulations.
Every penny of that had to be for product that was made in the United States. Everything had to be made in the United States.
The successful bid for the Millcreek project is a joint venture between Zenith Systems, Keystone Electric, and Solar Revolution, a local solar energy integrator.
We've done more installations here in Erie, Pennsylvania than the largest solar company in Florida. There's incentives in Pennsylvania where there's not in Florida. There's a 30% tax credit for residential. And then there's the Pennsylvania Sunshine Program. That's still huge. You got a huge payoff.
Joe, how much money do you think the township will save in electric bills?
The savings that we're going to be looking at right now is approximately $5,000 to $6,000 a year on electric bills. But the big savings is that when we produce electricity because of the solar panels, when you produce electricity, the electrical companies have to buy what's called green tags. Those green tags then go to the market. It's like the stock market. Who will bid the highest? And anticipated cost right now for buying those green tags from Millcreek is anywhere from $8,000 to $9,000. So there's a big savings right there. With the sun and the daylight, we're looking at between 15 years and 20 years to pay this system off completely, and then a cost savings for the taxpayers with a life expectancy of these panels at 45 years.
This is the future. You know, this reduces pollution. This will reduce dependency on foreign oils and foreign trade. I mean, this will create jobs in the U.S. by having more green jobs.
Richard Goffman is a LEED accredited professional electrical engineer for Keystone Electric's parent company, Zenith Systems. He and fellow professional electrical engineer Dave Wieland designed the Millcreek solar panel project.
The location geographically was in the right location, and the orientation of the facility, the available roof space that they had, whether it was on the garage or on the main building, it just really lent itself to a good installation.
Well, this project was like a perfect example of what you'd want to see in a building. this project lends itself from an engineering standpoint to this installation because how the roof was slanted. The coordination was pretty standard once you got into the building because there was plenty of space for us to work within the building.
A key element in the design phase is to assess the main goal of the project, which is to save the most energy with the amount of funding the township has to work with.
From there, we can start to get a generalized idea of which direction we want to head in, how many arrays do we want to have, what kind of equipment do we want to use, and then we start to refine it from there. Once we get our equipment selected, we can size all of our wiring, and the installation is all done by local codes, by the National Electrical Code, by building codes in the state of Pennsylvania. And that entire project is then documented onto our blueprints, reviewed by the local authority, and we can go ahead and get into our construction mode.
Construction mode begins with Jeff Bartlett, Rich Uhas, and Jim Kibbe from Keystone Electric surveying the site. As the field foreman for this project, it's Rich's job to plan and execute. His first task is to figure out how to get 400 feet of 3/4-inch conduit from the township building's basement to the roof with the least amount of obstacles. Armed with blueprints and a ladder, Rich starts knocking on doors and peeking into every nook and cranny he can get to.
Investigating the job.
No time for coffee or snacks. He's got to find out what he's getting into for the next 3 to 4 months.
Every job's interesting. Each one's its own little surprise.
Installing the conduit begins in the basement. It sure looks like a safe place to start. Rich thinks he's found a path from here to the attic, just below the roof where the solar panels will be installed.
It was a little bit of a congested area, so we wound up finding another area to go through. There was a pipe chase coming from basement to 3rd floor. There was access doors provided on the first floor and ground level floor. On the 2nd floor, we needed to add an access way to get into that pipe chase so we could extend our piping from the ground level floor up to the attic space. Once we got into the attic space, we were able to come across the trusses and come to the area where we're going to be penetrating through.
Running conduit throughout the building involves drilling a few more holes in walls, at the same time being very careful not to damage any nearby police cars. And check out the size of that drill bit.
The one we used to blow through these holes was 1 1/8" size we run through for a 3/4-inch conduit, and that gives us enough room that we can fire seal around it, you know, to meet the code requirements for going through fire-rated walls and that. It's a ride if he gets a hold of you. She'll send you for a loop.
As Rich and Jim connect and extend the conduit pipe across the basement, one thing becomes very apparent. These guys are perfectionists. Every step of the way is carefully measured and meticulously leveled.
I mean, no one wants to look up and see chintzy work left behind. Plus, the straighter it is, the easier it is for pulling your wire when you go through on it, making sure everything's tight. You know, if you have a loose connector or anything or go into a box, sometimes you're pulling wire, and if it's not fastened good, then it'll pull apart.
The crew connects, bends, and tightens 400 feet of pipe that will hold the wire for the solar panels, and another 250 feet of pipe for separate cables that will show a data readout in the lobby. With all the conduit routes in place, the trick now is getting the wire through it.
The next step we're going to wind up doing is we'll suck strings through our pipes and get lengths of what we need a wire to be pulled through. Pretty much we'll use a shop vac and a mouse, put a mouse at one end and a shop vac at the other, and turn it on and suck the string through the pipe. Once we do that, we can pull the string through and get a length of measurement of what we need for multiple cuts passing through. Tie the string onto the wire and put a guy at each end and just pull it through.
After a little cleaning up, no one even knows they were there.